So this is the briefing for the Ferrocene experiment. So what you're doing in this experiment is you're taking this sandwich complex here, ferrocene, which you'll learn a lot more about its structure and its properties in the second year sort of inorganic modules, and you're going to acetylate one of these cyclopentadiene sort of ligands to add an acetyl group. Now, you'll have some unreacted ferrocene in this reaction. So to purify this reaction, you're going to have to use a new technique called column chromatography to purify your acetyl ferrocene from your ferrocene starter material. And that's the main purpose of this experiment, is to teach you how to perform this technique for separating and purifying compounds called column chromatography. And in fact, column chromatography is perhaps used more often than techniques like recrystallizations and distillations in synthesis, but it's a very complex purification method, which is why we're introducing it at this stage. So we have a video showing you how to set up a column and run a column to separate mixtures of compounds. Do watch this video carefully, and as there's lots of different steps that you need to perform and run, and it's also a particularly different technique to what you've used before as well, so there will be a lot for you to process here. So do watch this video very carefully. So this is the basic principle of how column chromatography works. So firstly, you're familiar with the principle of TLC, how if you run a TLC, compounds separate on the silica TLC plate because they have different polarities, so they have different affinities for the plate, and they separate. It's that very same principle that underpins column chromatography. Okay, so what we have here is a column made up of silica gel filled with a solvent system, like a mixture of ethyl acetate and petroleum ether. And what you do is you load your mixture of your sample to the top of your compound, and then using gravity with maybe some bellows to exert some pressure to run the solvent through to run your column more quickly, you add some sort of solvent into the top, and you run your mixture through this silica column. And just like compounds separate on a TLC plate, the compounds in your mixture, your ferrocene and acetyl ferrocene, in this reaction will start to run down the column at different rates because of their different polarities. The compound with a stronger interaction, the more polar compound, will run more slowly, and the compound with a weaker interaction, the less polar compound, will start to run off, travel down the column first. And so that's how you get the compounds to actually separate out from each other using this technique. In the bottom of the column, you will collect the solvent in test tubes, and we call these fractions. Eventually, the first compound, the non-polar compound, will elute and reach the bottom of the column, and so they will be eluted into certain test tube fractions, and then in separate test tube fractions, the more polar compound will reach the bottom of the column. Okay, so then what we're able to do is in different test tubes, we've collected the different compounds, and then so we're able to separate the compounds using this technique. The final thing to isolate the compounds is to analyze which test tube fractions have your ferrocene and acetyl ferrocene, and then just evaporate off the solvent from the test tubes to leave your compound as a final pure product. Okay, so you've been allocated about 1.5 days to do this experiment. The preparation of acetyl ferrocene is something that takes about half a day. Okay, and what we advise is that you do this in sort of the afternoon session after you've done, say, the borane reaction, for example. Okay, and so to leave yourself a full day to run the column. Okay, so there's two parts to performing column chromatography. There's setting up and preparing the column, and then there's actually adding your sample and running the column and collecting the test tube fractions. Okay, and so because this is a very new technique and there's lots of steps to preparing the column and running the column, okay, you want to give yourself a full day to do this purification, so that you can take your time to make sure that you follow everything correctly. Because if you rush with the technique, then you get poor purification, poor separation, which obviously will affect your yields at the end. Okay, so that's the main thing. Give yourself the full day to do this, to do the column for this reaction. Okay, so that's the main tip that you can see in the tip slide. And the second tip as well is, okay, hopefully you get perfect separation of your compounds, so you get all of your compounds, all of your product into a separate test tube fractions to your starting material. However, in your analysis, if you're analysing and work and you find out that you've got some test tubes that contain both your starting material and your product, do not combine them with the test tubes that contain your pure product, because otherwise in your final sample you'll have impure product. Okay, so that's the second main tip for this experiment, and that concludes the briefing for the Ferrocene experiment.